Okay, good morning, everybody, and welcome to my talk. This talk is going to be about analyzing Salesforce data using technologies on Heroku. My name is Arthur Louie. I'm a developer on the Heroku Connect team at Salesforce. I've been with Salesforce for about 5 years, and prior to Heroku, I worked on the core Salesforce app as well, on Chatter and APIs. And so this talk sort of touches upon a lot of the things that I've worked on. So before we begin, just a note about forward-looking statements. I am a Salesforce employee, and if there are any forward-looking statements, please do not use them when making purchasing decisions. Any purchasing decisions should be made based on currently available functionality only. So with that out of the way, the talk is about analyzing Salesforce data with Heroku, Kafka, and Connect. And my motivation for doing this is that Apache Kafka on Heroku was just GA'd like last week. And it's very exciting. Over the summer, we had been beta testing it. It was in a public beta. And I was really curious about it. I'd heard great things about Kafka, but I'd never really used it before. So this was a great excuse for me to put something together as a demo to sort of get a feel for what Kafka could do. And so I have this demo that we're going to be working on throughout this presentation. It's about real-time sentiment analysis of chatter data. Now, I'm not using any Einstein stuff or anything like that. Back in the summer, I didn't even know Einstein was a thing. So I'm just using some open source technologies to do sentiment analysis. Pretty simple sentiment analysis. But the real meat of it is the analysis in Kafka and moving the data out of Salesforce. So I guess we should take a step back. Like, why would we want to supplement Force.com with Heroku in the first place? Force.com offers some very, very good data processing solutions. But as your data volumes grow larger and your analysis becomes more sophisticated, you'll find that you might outgrow the limits of what Force.com can provide. So on Force.com, you've got things like governor limits and Salesforce API limits, SOQL limits. These are all things that you don't have to worry about if you put the data into Heroku. Now, it's not that computation is unlimited in Heroku, but it's just much simpler to scale things up. If you need more hardware, it's as simple as clicking a button or typing in a command at the command line to scale up your hardware. On Heroku, you can also choose to develop in whatever open source language you like. So Heroku supports a large number of them, and you can use their associated libraries and all the things that people have built up in the open source community. On Force.com, you're very much limited. There aren't any nice utilities for a lot of the more advanced data processing that you might need. Heroku also has specialized add-ons. There are some add-ons that Heroku provides itself, such as Heroku Connect, Postgres, and Kafka. There are also many add-ons that are provided by third parties to do things like help you monitor your application or help to test your application or to help with logging. So there's a large ecosystem of partners as well. So hopefully that convinces you that it's a good idea to move your data from Salesforce to Heroku to do more advanced processing. If you want to do this, what are your options? So there are 3 options that we're going to describe in detail. The first option is something provided by Heroku itself, Heroku Connect. That's the product that I work on. And there are 2 other options that are provided on the Salesforce side of things. So the first one, Heroku Connect, for the wide majority of use cases, it is a great solution. And it's super easy to use. The basic idea is that it syncs data between Salesforce org and a Heroku Postgres database. So if you make the changes in Salesforce, those changes get reflected into Postgres. And if you make the changes in Postgres, they'll get reflected into Salesforce. It's super simple to use. It's got a point-and-click interface. You basically authenticate it with Salesforce. You're provided with a list of objects that you want to sync. You select the fields, you click some buttons, and then the data schema gets created in Postgres. There's an initial sync that, that synchronizes all of your data. And then from that point forward, the changes are mirrored between the two. So really nice solution. It's very elegant. The syncing mechanism is poll-based, though. And so you need to configure a polling interval. And for the paid version, it gets as small as 2 minutes. So every 2 minutes, we poll Salesforce to see what are the changes since the last poll. So because of that, this is not a real-time solution. In most cases, it's good enough to have like a 2-minute lag or maybe even a 10-minute lag. But if you want to do some analysis in real time, like what we want to do, then this isn't going to be the tool to use. So we have to investigate the other, oops, wrong way. We have to investigate other solutions. So the two in Salesforce, the first one is workflow outbound messages. So this works as part of workflow in Salesforce. So you create your workflow rule. You say, if a certain object changes and the fields are within these values, then you do something. And most of the time, you do things like create a task or email somebody. You can also send a message via SOAP. So what you do to configure it is that you select the fields that you care about, and you have an endpoint that is hosted on Heroku in this case. And then when your workflow rule fires, then that data will get sent via a SOAP message to your web service. So a limitation is that it is SOAP only. You can't use REST in this case. There is a delivery status UI that's it's very nice. You can see how your messages have been delivered, and if there have been failures for whatever reason, there's a nice retry mechanism. So if your SOAP web service is down, you can it retries automatically for you. So that's the declarative solution. And there's also a programmatic solution in Apex. And if you're familiar with Apex code, it's quite simple. You can use Apex HTTP callouts to send the data over. So for any triggerable object, you're given the data that's changed in the trigger, and then in your Apex code, you would just call a future method that executes asynchronously to send a REST request to your web service, which again is hosted on Heroku. So to summarize, you've got the Apex solution, which is the only one that requires code. Everything else is declarative. Workflow and Apex are real-time. And Heroku Connect supports most S objects, not all of them, because not everything has the fields that we require to do a reliable sync. Workflow supports most S objects, but not all of them. And Apex, there's only some objects that are triggerable. And in Workflow, it is the only one that only supports create and update. The other two also support delete. So this is the goal that we're going to work towards in this demo. We've got for real-time sentiment analysis of chatter threads. So you've got your monkeys typing in your chatter post into Salesforce. You want to send that chatter information into Heroku, do some analysis, and we're going to write back the results. In our case, the sentiment analysis is going to tell us what are the most positive threads and what are the most negative threads. And so we'll post that back to Salesforce. So looking at our table again, because we want real-time support, we can't use Heroku Connect. We've got to use either Workflow or Apex. And in this demo, because we care about chatter data, it turns out that in Workflow, chatter comments aren't supported. So we're forced, in this case, to use Apex. So that's what we're going to do. We are going to write some Apex triggers that do the HTTP callout into Heroku. So let's take a look at what that looks like. I've got some trigger code here. Like I said, it's very simple. In the trigger, on the top there, you see that we just serialize the information that we get from the trigger. That's the information that's changed. And we send it to this doPost method, which is an @future method. It executes asynchronously. And it's going to post to our endpoint that's hosted on Heroku. It's this herokuapp.com/sfdata. And so that's what is going to move our data onto Heroku. And so the first part of the demo here, I wrote a simple script that posts random chatter data. It does what the monkeys do in the picture. So I found a publicly available Facebook data set. And so it's like all of the posts and comments from a small town's Facebook group. So I've written a script that just pumps all this data into Salesforce. So I'm going to run it. You'll see some stuff fly by here. So this is all random. It's we'll see what we get. I hope there's nothing too off color, but I mean, this is like hundreds of megabytes of data, and it's just choosing random stuff to post into Salesforce. We can see that it's happening if I go into my Salesforce org here. I'm in Chatter, and if I go to the all company feed, I can see that today at 11:40, which is the current time, things are being posted, and I'll reload it, and you've got some new stuff there. So we're just going to let that run throughout the talk, and at the end, we'll do some sentiment analysis of it. So you've got the monkeys running in the background, and the Apex trigger is sending this chatter data into Heroku via an Apex trigger. So in my Salesforce org, I already have these triggers installed. And so when these monkeys are posting, the Apex triggers are sending the data into Heroku. So once it's on Heroku, what happens? And this is where the really interesting part is. We're going to send it to Apache Kafka on Heroku. This is Heroku's Kafka as a service. I'll give some background about Kafka. Kafka is a highly distributed commit log. And then what that means is that you can write data to Heroku. As long as that data doesn't change afterwards, it's immutable, we can process it at very high volumes very quickly and with a lot of resiliency. Kafka originated at LinkedIn, and it has since been adopted by all sorts of companies. I saw a presentation with Yelp yesterday upstairs. They're talking about how they use Kafka as their event bus. Heroku itself uses Kafka in its platform event stream. Facebook, Uber, you name it, it's become an industry standard. So, and it's become very popular because it's fast, it has certain guarantees about delivery, and very importantly, it supports independent consumers. So you can write things into Kafka, and you can have separate consumers consuming the data at their own rates, and they don't affect each other. So you can, and this scales massively. So you can have any number of consumers, and as long as you throw more hardware at the problem, then you have nice scaling. So Kafka's been known to be used for real-time stream processing, website activity tracking, metrics collection, log aggregation. Any scenario really where you have a stream of data that you want to write once and then read afterwards, but the data is immutable. It doesn't change after you write it. Some basic terminology here. Topics are user-defined categories that you write data to. So when you set up Kafka, you create any number of topics. You just give them names, and your producers are what write messages into those topics. So you've got producers, any number of producers writing into a Kafka cluster, and then any number of consumers reading from that Kafka cluster. The consumers subscribe to topics, and then they get essentially a feed of data from those topics. So I'm just going to show the Heroku app I've got here. So I'm in Heroku. I've got this app that I have created. It's called DF16SF Kafka Demo. And I already have Kafka attached to it. If I didn't, I would just click on add-ons there and search for Kafka. And then it's very easy. You've got some price points here. The really nice thing about Kafka on Heroku is that it's a hosted solution. One of the biggest pain points if you're setting up Kafka on your own without Heroku is the operational cost. And it's that operational burden that Heroku removes for you. So Heroku takes care of maintaining the Kafka cluster. All you do is you get the information that allows you to connect to the Kafka cluster, and then you use it. So that's what my app looks like. There's a UI for Kafka. If I click on this, you get some basic statistics about what's happening. We also have a very rich command line interface. So I've got the Heroku Kafka info command, and so I can see that I've got a certain version of Kafka. I've got 2 topics defined, and I've got some traffic coming into it because of this these monkeys typing stuff into chatter. So that's what Kafka is. Let's take a look at what my Kafka producer, is going to do. So this is the thing that writes data into the Kafka cluster. So the code is very simple. This is in Python, but it doesn't really matter. You'll remember that in my Apex trigger, I was posting to like herokuapp.com/sfdata. So the first line there is just defining what that route is. What this code does is it basically it takes the serialized S-object data that's being passed in by the trigger, and it's filtering it down to only the fields that we care about, and then it's writing that data into Kafka. I've got all this in GitHub, and I'll have the links to that afterwards. It's very simple, but I have removed some of the details from here. So that's my producer. It writes into Kafka. Now we have separate consumers as well. And this is even simpler. The way consumers work is that they subscribe to topics. So you can see here that my consumer is subscribing to the chatter topic. And then all it does is it iterates, like for message in consumer, that is iterating over all of the messages that are being sent to the chatter topic. So this is an indefinite loop. It just keeps on looping. If there's no data being written in, it just waits until some data is written to this chatter topic. So very simple. My example here is just printing out some of the stuff that I get, but in my actual consumer, this is where I do the sentiment analysis. And I just call this open source text blob library, it's called, and it just tells me, I give it some text, and it gives me a sentiment score from like -1 for the most negative to +1 for the most positive sentiment. So yeah, that's basically it. The sentiment analysis analyzer calculates the sentiment for each thread that comes in. It keeps a running total, and when it exits, then it knows what the most negative thread is and what the most positive thread is. So I'm just going to run it here. So my monkeys are still typing into chatter. They're not stopping. But I'm going to run my consumer here. And it's just running from my laptop, but it's connecting to the Kafka cluster that's on Heroku. And I've got an error here. Let me try it again. I'm not sure what that error is. But what should happen is that it should connect to Kafka and start analyzing what's wrong here. Man, I hope this works. I got this error just before I was doing the demo too, but then it corrected itself, so yikes. Let me just do another Kafka info here. Cross my fingers that it works. It's working now. Okay, I'm not sure what that was, but the consumer is now catching up. So things operate independently in Kafka. The monkeys have been writing the entire time, and the consumer is going through what the monkeys were writing into the chatter topic, and it's going through all the messages and analyzing each one of them for sentiment. So I think it's caught up now. It's pretty quick. And so if I stop the monkeys, actually, yeah, I'll stop it there. So nothing's being written into Kafka anymore. And you can see that my consumer, it's still running, but the output, which is just like it's just printing out what was in the Kafka feed, it's stopped. So I haven't stopped my consumer yet, but when I do, it's going to identify the most positive and negative threads. And I'm going to take that information and post it back into Salesforce Chatter. And I could do it with Salesforce API calls. That's a direct way. But another way is with Heroku Connect. And you'll remember at the start of the talk, we talked about how Connect can synchronize data between Salesforce and Heroku Postgres. If I have a Heroku Connect instance that's connected between Salesforce and my Postgres database, then all my consumer has to do is write into the Postgres database for like, I'm going to do a chatter comment in this case. It's going to write a comment into Heroku Postgres, and that will get synced automatically into Salesforce. So let's do that. I'm going to stop my consumer. And so it's identified the most negative thread and the most positive thread. So let's take a look at these. This is totally random, so who knows what we're going to get. I hope it's not anything too off color, but we are going to look at the most positive thread first. Let's see what it is. So we're talking about a lovely weekend, something's the best. So this is an extremely positive thread, so good job, sentiment analyzer. You can see that here, whoops, let me see. In the comment that was posted, you can see that it was posted via Heroku Connect. And so that's kind of the proof that I didn't actually use my own API call. I wrote into Heroku Connect, Heroku Postgres, and Heroku Connect did the syncing. So you want to see the most negative thread, maybe? Let's see what we've got for the most negative thread. Now, usually these threads aren't like super negative. Let's see. Toke in Melrose Park has found some photos. Okay. Lovely cat passed away, probably hit by a car. Wow. So this is very negative. This is actually the best negative thread I've found so far. So this is great. So we've done our job. We've done some analysis in real time using Kafka, and we've identified the most positive and negative threads. And to go through the workflow again, we had these monkeys posting information into Salesforce Chatter. It was Chatter data, but it could very well have been accounts or contacts or anything like that. With Apex triggers, we moved the data into Heroku. In Heroku, our producer wrote into Kafka. We had a separate consumer that consumed that data in real time and did analysis of it. And then we wrote it all back to Salesforce, completing like the circle of life via Heroku Connect. So that's pretty much it for the demo. As I said, the code is all on GitHub. My username there is alouis-sfdc. You can check out the code to get some ideas of how you could use Kafka, and I'm using Python in this case, but there are a number of libraries and a lot of different languages. I have some information here about Kafka. We've got all sorts of resources, both from Heroku and from the Kafka community. There is a lot of information about Heroku Connect. If you do want to talk about Heroku Connect, very happy to chat with you afterwards about it. And just some basic information about Salesforce and Heroku integration as well. This Trailhead module is really good, and it's actually where I started when I wanted to investigate more about how I could possibly use Heroku to complement Salesforce. So thank you very much. I hope this gives you some ideas of things you can do to use Heroku to analyze your Salesforce data. I'm happy to answer any questions here now. I think we have a bit of time left. There are a couple of microphones. Yes, hi.
Quick question. If I have an instance of Kafka on-prem, is there any issue with doing the same thing?
Could you turn up the volume a little bit, please? I had trouble hearing that. Yeah. Sorry, could you repeat the question?
If I have an on-prem instance of Kafka, is there any problem doing the same thing that you just did?
No, you could do the same thing. So the advantage with Heroku, if you have your on-prem version of Kafka, It doesn't matter. It doesn't have to be hosted on Heroku. The Heroku solution is just a very nice solution for reducing a lot of the operational burden. Yeah, thank you. We have a question here.
Hey, this may be more of a Kafka question, but the producer is posting, messages over to Kafka. Can you go through those messages multiple times?
Yes. So the question was, you've got stuff being written into Kafka. Can your consumer go back and read over those messages multiple times? And yeah, so your consumer actually is responsible for keeping track of where it was. In my loop, I just showed, it's just reading the most. It's just reading them in sequential order, but you can go back in time. So because Kafka, like within a particular topic, the ordering is guaranteed. And so within a particular partition of a topic, the ordering is guaranteed. And so you can go back in time. It's called an offset. You change your offset, and you can just, so if you want to analyze something and you want to go back and do some more analysis of it, you can do that very easily with Kafka.
And then the follow-up question is, can you have multiple consumers working on the same stream, just processing different logic?
Yes, you can. You can have multiple consumers working on the same topic stream. That's right. There's some great demos in the Heroku booth as well of Heroku Kafka and Connect. Yeah.
Under the hood, how is the producer communicating with Kafka? Can you talk a little bit about the protocol it uses?
It has its own protocol, so it's not HTTP. Kafka has its own protocol. I don't know very much about it, but it's its own protocol. Yeah, so the libraries take care of everything. Yeah, thanks. The libraries take care of everything.
So there was another session this morning talking about event, right? They support Bayesian and Comic D. Right, so how you compare this two? You have the Kafka with Heroku.
So you went to another session today.
Yeah.
Was it upstairs? In a room upstairs?
Yes, probably, yeah.
Okay, yeah.
You have two eventing protocol, eventing architectures.
Yeah, I think I know what you're talking about. And this is the Salesforce solution for
Salesforce,
evented architecture.
Eventing architecture, yeah.
Yeah, there's some interesting stuff on the Salesforce roadmap, and they actually use Kafka under the hood as well.
They haven't. They will support Kafka, but not now. That's
okay.
what they said, yeah.
Okay, they have their own.
The Bayesian protocol and Comet D, right? But they said they are going to support Kafka. Yeah.
I guess they're moving towards it. Yeah. This is a solution that is, I think, independent of what we're talking about here,
right.
But we do it in Salesforce for detecting changes. We do want to move more towards this kind of architecture as
Okay,
well.
fair enough.
Yeah.
Thank you.
Thank you.
Did you have your Heroku, your Kafka consumers running on Heroku too?
So that's a good question. The question was my Kafka consumer itself running on Heroku? In this demo, it wasn't. It was just running on my laptop. But I could have pushed it to Heroku to run the consumer on Heroku as well. There's nothing stopping me from doing that. I chose to do it on my laptop just so that I could do Control-C and stop it easily. But yeah.
Is there any advantage to having the consumers run on Heroku? Like,
yeah, absolutely.
do they share network space or something?
So the question was, is there any advantage to having the consumers run on Heroku? And absolutely, you don't have to maintain the server yourself. So if you could take advantage of Heroku for just the things that Heroku is known to be good for. You don't have to. You just set it to run, and it runs, and you don't really have to worry about it. You can scale it up easily. So I would actually recommend running the consumer on Heroku as well. Okay, looks like that's it. So thank you again very much for attending my talk.